going to do is we're going to review the factor trees. Because, it's okay if I did that. There were some issues with factor trees on the homework that I collected the other day. And I need to make sure that we clear up these issues because we're going to do factor trees again today. And if you can't, if we make mistakes, we're not going to get today's work right. A couple of things I want you to look at. When you make a factor tree, you need to put these away. When you make a factor tree, you are making, basically, you're going down and you're kind of making a list of all of the factor pairs, which are the numbers you multiply together, that make up the number above it. Okay? Yeah.
For our homework, they were saying 3 and 3. That's 2 and 3.
Oh gosh, no, on 6, it's 2 and 3. It's 2 times 3. Yeah, I saw that. We're gonna get to that. Hang on a second. Like I said, it doesn't matter what you use as your first pair, except that you never use 1. And I saw some 1s across everybody that did it. You need to have yours open to the right page. You never use 1 because really it's just 1 times 36, and then you're going to start again, right? We always just assume. It's in your binder, hon. Your notes from your binder. You always assume that the 1 is always going to be there, right? You don't worry about it. You pick a pair. Doesn't matter what pair. I did 6 times 6. I could have done 4 times 9. Doesn't matter. As long as you come to the same end, which is the 2 with 3, the 2 and the 3. All right? Every time you get to a prime number, you circle it and you stop. Some people stopped, on a homework, like one example, I saw somebody with a 4, left a 4 and stopped. 4 is not prime. You have to keep going. You need to remember that if it has anything you can divide it by, it's not prime other than 1. And remember that list of 10 first-time prime numbers? If you have that memorized and you can recognize those numbers, I can't imagine as 5th graders especially that we're going to ever get any bigger than, what was it, 29 as a factor. So if you have it memorized, you should be in good shape. The other thing that you need to remember is when you start making your list, notice I have 2, 3, 2, 3. Remember I told you that when we remake the list, you need to make it in order from least to greatest. Okay, and I saw some skipping around. I saw there was one on the homework that was like 2 squared times 5 times 7 or something, and I saw 2 squared times 7 times 5. Remember I said in number order. All right? Other thing is, 6, you're always multiplying, so it's not 3 times 3, which I saw a fair number of them. It's 2 times 3. Okay, 3 times 3 is when you add. We're multiplying. And kids do that a lot. And you know what? Kids do it on 10, too, a lot. I see it all the time. Like last year, instead of doing 2 times 5, they do 5 times 5 because they're thinking adding. What this tells me is you need to slow down. You need to remember that you're multiplying, and you need to work carefully and precisely. Okay? These are little mistakes, but if you did it wrong, you had this wrong. Those little mistakes would cost you a lot of points when they're not necessary. You guys all know 2 times 3 is 6. You just had a brain cramp that moment, right? Slow down. Don't lose those little tiny points. Save the points you might lose on a test or a quiz on the stuff you don't know, not the stuff that you do know. Okay? Basically, we call that a careless error. We don't want to do careless errors. So what I was trying to say, another thing was the in order part. Make sure you're doing them in order. Emily. Right. Again, I know it's hard to keep the multiplication, division, or the multiplication and adding stuff a little bit separate, but your brain just has to really make sure, especially like when you do multiplication problems and you have to add that second part. You got to stop your brain and say, okay, brain, am I supposed to multiply or add? And do it. So basically, you need to slow down and think about it, right? Okay, somewhere on this page, I'd like you to do one more tree for me. Maybe squeeze it in at the top. No, we're going to do our own tree. We're going to do a new tree. So somewhere on this page, I'd like you to do another tree. So kind of don't erase, just work up here, work at the top, turn it sideways, whatever. we're going to make a tree for 120. I want to do one more practice tree to make sure we're getting it. Now, again, there are many different sets of pairs. You can do 10 times 12, which a lot of you probably think immediately. You can do 60 times 2, 30 times 4, 40 times 3, yada, 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 right? Whatever works. There's a lot of choices. Does it matter? No, because you're all going to end up at the same prime factorization. Yes, because a number only has one prime factorization. No matter how you get there, there's only one. The only thing that you're not going to do is use what? 1. You are not going to use a 1. Now because I want to make a point, I'm going to use 2 times 60 because I want to make a point. You do it however you want. If you want to do 10 times 12, or you can do 2 times 60 to go with me. 2 is prime, so I'm going to circle it. Remember, every time you get a prime number, you circle it. Suggestion, maybe it would help you if you had a different colored pencil with you or a pen, so that when you got a prime number, you circled it with a different color, so that when you get done, you can see what ones you still have, maybe make sure that you've got them all. They jump out at you a little bit better. So you can definitely use that as a strategy. My 60, I'm going to use as 6 times 10. Again, it doesn't have to be that way. Are those prime? No. So I'm going to keep going. 6 is 2 times 3. Oh, yep, those are prime. 10 is 2 times 5. And those are prime. So now I've got every branch of my tree ending in a prime number. So I'm done. Remember, you are not done until every single branch of that tree is ending in a prime number. Yep. Now, this is why I made the point of doing it this way. I saw some people on their homework doing something like this, which is fine. But what happened when they got to the end and they were making their list is I noticed that, like, for example, this were someone that was making that mistake, did this and forgot. I'm assuming, because whoever did this was 1 too short. I'm assuming what happened was they forgot to look back up here because it was way different. You really looked here and you forgot to kind of look back up. It was because the people that did that, their 2s were so far different from the rest that I'm pretty sure that's what happened. That you missed this one and got all the rest. No. 2 times 2 times 2. 3, 5. 3 2s, 1 3, 1 5. Yeah, you should. No matter how you do it, you should all get the same. Chris? Quickly. Yep. Shh. Okay? Now you combine. Remember, just go. Remember when I rearranged, look, I had 2, 2, 3, 2, 5, but when I rearranged them, I put them in number order, right? Now I'm going to combine what I can combine. I want you to try to do the combining. Definitely you have to do this, and actually tonight I'm going to make you stop here. But I want you to try the exponent combining. I know that you're not as familiar with exponents as my 6th graders are, but I want you to try it. Okay? I want you to be trying it. Chris? Tonight you're not going to, no, because we're going to work from this spot. Okay? All right. So, nope. Next page. Greatest common factor. Turn the page. We got to hurry, guys, because we got a late start because of all those clippings of the note cards, so we got to kind of move along. We already talked about what a factor is. A factor is a number that you multiply with another number to get a big number. Remember we talked about how it's a building of a number? That if you multiply together, you build a number, just like in a factory. Okay, so that was the hook with the factor, is a factory. You're building these numbers. There you go. In the case of 18 and 24, which I have here on the whiteboard, paying attention please, I made my list of factors. These are all factors. If they're together, we call them a factor pair. Remember that was on your crossword last night, the factor pair. They're the pair that go together to make the bigger number. 2 and 9 are a factor pair for 18. 3 and 6 are a factor pair for 18. Okay? One single factor is the one number. The 2 together are factor pairs. Now, common factor is when you take and you're looking at like 2 numbers, 3 numbers, and you're seeing which ones are in both lists. So like on this list of 18 and 24, the 1, the 2, the 3, and the 6 are on both lists, right? So those are the common factors. The other ones, because they're not in both lists, we're not going to worry about them. If you had 3 numbers, they'd have to be in all 3 lists, right? To be common. Common means like the same. Greatest common factor, or GCF, which you need to learn what that means and make sure you have that, is when you're taking the biggest one. Because there are 4 common factors, 1, 2, 3, and 6. But we want the biggest one, the greatest one, which is 6. Okay? In that case. Greatest common factor is finding the largest factor that they all share.
Oh, that's way easier than
Yeah, it's not that bad. Now, there's 2 ways to do it. Okay? I'm going to teach you both ways. You need to learn both ways. Because if it tells you specifically one way or the other, you've got to do it that way. All right? Remember, it's not just about the answer. It's about the entire project, the entire problem. If it says find it using a list, then you got to do it using the list. If it says find it with prime factorization, which is the other way, then you got to do it that way. If it doesn't say, then you get to choose. Okay? But if it says, you got to do it. So, first way, find the greatest common factor using a list of factors. So this is where you're going to start working in your notebooks. All right? Step 1, list the factors of each number in order from least to greatest. See, on the right-hand side, we have like an example problem going here. Find the GCF of 18 and 30. So we're going to list our factors, which means we're going to make our little factor charts. And we're going to do it the way I taught you so that you don't skip anything. Starting with 1. 1 times 18. 2 times 9. 3 times 6. Does 4 work? No. Does 5 work? No. Does 6 work? Yes, but we have to stop when we repeat. So we're done. Okay? So over here, we're going to make our list of the factors of 18. Because my directions said to list them. If my directions didn't say to list them, you could probably just leave it in the chart if that works for you. But if it says list, you gotta list. You gotta read those directions. 30, same thing. 1 times 30, 2 times 15, 3 times 10, 4, nope, 5, yep, 5 times 6, and then 6 would be repeating. So my factors of 30 are 1, 2, 3, 5, 6, 10, 15, 30. By the way, the other day when you did the factors of 36 and you had 6 times 6, you only need to list the 6 once. You don't have to put 2 6s. You don't have to do 2 6s. Because yeah, you don't have to use it. Yes, sir. I do, yes, I believe. So, looking at that list, we're going to circle the ones they share. Okay? Now, if they match up, you could make one big circle, but I usually just, because they end up not matching up at some point. They share 1, they share 2, they share 3. Nope, not 5, but 6 they share. Nope, not 9. Nope, not 18. Nope, we're done. Yep, I do, because that's what it says. That's step 2, by the way, circling the common factors. So step 2, circle those common factors. Okay, do it carefully. Now, so what I do is I circle them separately, and then I go, 1's a common factor, 2, 3, 6, and I have nothing bigger. So what is my biggest one? 6. Okay? Now, I found my greatest common factor, the largest one. I want you to write this in a certain way. First of all, cross that bottom part out because I forgot something when I made these. And because I want you to do it a certain way. Okay, and if you don't do it a certain way, you're going to miss a couple points because we need to be doing ours completely, precisely, and to the best we can. When you do it, I want you to write GCF, and then you're going to have a set of parentheses. And in the parentheses, you're going to have the 2 numbers that we compared, or 3 if you have 3, equals, and then whatever the GCF is. Basically, what you're doing is writing a sentence. Okay, so this is like the example that you would use. So in the case of what we just did, the GCF, we did 18 and 30, right? By the way, these should, again, be in order. Don't put... Yes. Well, you're going to writing this top one as your sample of how they all should look. And then this is this one we just did. Okay? And they should always be least to greatest, by the way, equals 6. That is the final answer of this work. But remember, it's not all about the answers. It's about the entire process. Okay? I will be looking at the whole process. You need to get all of it right. It's not just good enough that you find the final answer. You need to understand all the ways to get there. All right? So, yes, sir. Ooh, quickly. I'll give you a copy of the rest of the notes, okay, Nathan? So that's how you do it with a list. Girls, is something wrong? Okay. And Maddie, really, I mean, that's nice of you to help, but she needs to, make sure you guys are with me. What I did was example blank and example of the real, okay? Where do you usually sit? Right in there somewhere, right? Was there an extra pencil bag? We haven't seen, nobody's given me one, so maybe you lost it in the earlier class. Oh, there it is. Is that yours? Awesome. Thank you. All right, so that's how you do it with the list way. Next page, we got to keep moving. We're going to use it doing the prime factorization way. Okay? Like I said, there's 2 ways to do it. Prime factorization. When I say prime factorization, what do you have to do? And it may not tell you. What do you have to do, Colton? Make a factor tree. Prime factorization always means tree, even if the directions don't say so. Okay, in this case, I did write them because I wanted to make sure you had the complete. On your homework, I don't believe it says tree. I think it just says using prime factorization. Because you need to know that prime factorization, the way to get there is make a tree. So, whatever numbers we have, we're going to make trees for them. That's step 1. And we're going to list that prime factorization. We're not going to use the exponents part. We're not going to, no exponents. Okay? We're going to stop at the step right before. Step 2, we're going to look at, find, and list the common ones, the common prime factors. The ones that they all share, both of them, if it's 3, whatever. And you know what, Braden, it's what you're used to and what works better for you. Yeah. So I'm not as used to this one. I like the other one a little better because I'm more used to the other one. But this one works pretty well too. Then when you're done, you take all the ones they shared and you multiply them together, and your answer is the greatest common factor. Yep. So because we're basically building the greatest common factor. All right, so let's do the example that's on the bottom. And then we're going to do another one because I'm going to prove to you that it's the same. But first we're going to use this example. We're going to find the greatest common factor of 36 and 54 using prime factorization, which means I have to do a tree. Did it say so? No. All right, so I'm going to do 36 and I'm going to do 54. Please do one tree at a time. Work carefully. Go ahead. Yeah, you'll get confused. Go ahead and make your trees however way you choose, if you want to do 6 times 6 or 9 times 4. But when you get done, I want you to check the board and make sure that your prime factorization is the same as mine. Okay, because again, we can do these more than one way, and you can choose. But you have to, no matter how you do them, we're all going to end up with the same. So if we're not the same, then you have made a mistake somewhere. Okay. 36 should be 2 times 2 times 3 times 3. Remember, you organize them, least to greatest. And 54 is 2 times 3 times 3 times 3. Keep going. That was step 1. We found the prime factorization using the tree. Step 1. I'll let you catch up, and then we'll move on to step 2. No, well, I don't care, but you don't need it there. Okay, now let's look at, now here's the kicker. Pay attention to this, okay, because you really need to realize this. These are individual factors. Yes, I know they're the same numbers. Doesn't matter. We're going to keep track of them separately. So in this case, there's a 2 here and a 2 here. So we're going to circle them because they share that 2. But do they share a second 2? No. So we're going to cross the second one out because there's not 2 of them in both, just in the 1. Okay? And then the 3, they share, here's a 3, here's a 3. Do they share this last 3? No. Okay, but you see how I counted each one separately, even though there's more than 1, 2? You have to count them separately. Now we're just going to make a list of the ones we circled. So basically this is 2 times 3 times 3, right? 2 times 3 times 3. This is how I want you to do it. And then step 3 was multiply it together to get the GCF. 2 times 3 is 6. 6 times 3 is 18. So the GCF, and remember I expect you to write it this way. Were my numbers 36 and 54? Of 36 and 54 equals 18. Okay? So really, it's both ways are very, equally good ways to do it. Like I said, if they tell you a certain way, you got to do it that way. If they don't, you can choose the one that works better for you. And you guys may be different because people think differently. Now, somewhere on this same page, squeeze it in here, we're going to do one more set with the prime factorization tree. So I want to prove to you that, and you can even write sideways. I don't care. I'm going to prove to you, just turn it sideways and write, that it works. On this page, we did 18 and 30, right? And we got 6 as our greatest common factor. So let's, on this page, I'm going to make the second page here for me. Let's do 18 and 30. Let's just see. Let's do it this way and see. If we get 6 this way also, well, you should, but let's just see. I want to prove it to you. Again, it doesn't matter which set of factor pairs you use as long as you're correct about it. So you could have done 2 times 9, just not with the 1.
How did you use the 6 times 3 on a top base?
Huh?
Never.
And then you're going to organize them. Remember to make sure you're doing them off. You're going to, if it helps to cross them off, remember if it helps to make them a different color, whatever needs to happen for you to make sure that you get them all. So there's my list of prime factorizations for both trees. So I'll let you catch up. Did I? And then, basically, we're going to look at it and say, well, there's a 2 in each one. There's a 3 in each one. But there's not a second 3, and there's not a 5. So they share, just watch for me, I'm going to give you a copy of this, okay? You might have to ask a friend in study hall or something for some help. Or you can, I'll have the video online so you could watch it. You can even get to it off of YouTube if you need to. They share 2 and 3, right? 2 times 3 is 6. Isn't that what we got doing it the other way? Yeah, so it works. It's the same. So we're going to write out for our answer the GCF of, it was 18 and 30, right? Equals 6.